All right, so for part A, we need to find the critical numbers of G. So what that means is that we're going to need to find the derivative of G and find where the derivative is zero, or where the derivative is undefined. So let's first find the derivative, and that's going to involve the chain rule along with the product rule. So the derivative of G of X equal to, we're going to use the power rule here. 3 times 2x plus 4, that all to the second, times the derivative of the inside, so times 2, multiplied by x minus 6, plus, now we keep this first group constant, and then we multiply by the derivative of x minus 6, which will just be 1. And then we can try to simplify this a little bit. So we're going to have 6 coming out from here. Now, from each of these, you can factor out 2x plus 4 squared. So we're going to take out 2x plus 4 squared. And that'll be times 6x minus 6. That'll be this first part right here. Plus a 2x plus 4 to the 1. And let's just like simplify the inside now. G prime of x will be 2x plus 4 squared. That'll be 6x minus 36 plus 4. So 8x minus 36 plus 4. So minus 32. Okay, so here's our derivative. Now we just need to find the zeros of this. So we're just going to set 2x plus 4 equal to 0. And then 8x minus 32 equals 0. And then solve this for x, we'll get x is negative 2. And x will be, and x is 4. Also, just double check to see if there are any values that the derivative will be undefined for, because that would also be a critical number. But this is just a polynomial, so there's no undefined values. And so our two critical numbers are negative 2 and 4. All right, now in part B, it's asking for what values of x is the function g is increasing. Like, where is it increasing? And that's what the critical numbers are usually used for, because this tells you where there could be a potential like maximum or minimum, or maybe just like a weird like concavity. Something is going on here, or something possibly could be going on there, which is going to be important. We're going to analyze our graph, and we're going to break it up into the intervals at these points. Now, since this is a polynomial and there's no undefined values, we're going to go from negative infinity all the way to positive infinity. That'll be our total domain. We're going to break up our intervals at negative 2 and 4. And then so we want to see what's going on in these intervals with the derivative. So what we can do is just test a number in here. You can just test and figure out what f prime of like negative. It's like negative 10 could be. And what would be like f prime of 0? F prime of 10. We just need to know the sign of the derivative at each of these intervals, or at each of these points specifically. Once you know the sign, that's going to help you determine if the graph is increasing or decreasing, and then you can figure out if there's going to be a maximum or minimum, or neither at these points. So we just plug in negative 10 into this equation, and actually I should be putting g because they're functions. g of x. Let me just change those because that was confusing. So if I put -10 in there, on calculator, so again, don't spend too much time doing tedious calculations. You just want to figure out what the sign would be. So if we put -10 into here, we would get -20 plus 4 squared, and any number squared will be positive. So you're going to have basically a positive number times -10, -80, minus times a negative number. So you're going to have a positive number times a negative number. And so the derivative is going to be negative. If I plug 0 into here, again, any number squared, so 4 squared, this is going to be positive. So you're going to have a positive. If I plug 0 into here, I'll have a negative. A positive number times a negative, so I'm going to have a negative number here as well. And now if I plug 10 into here, I'm still, remember, any number squared, positive. 10 here, 80 minus 32, that'll be positive. So here I'm going to have a positive derivative. And so then, like, what is the graph of g of x doing? Well, the g of x is decreasing here, and it's increasing on this interval because the derivative tells you what the function is doing. It's decreasing along all the way to 4, then at 4 it increases. So then there's a relative minimum here because it goes down then up. We could say there's a relative minimum at x equals 4. And then that answers part C.